We continue our journey of discovery of the language C by looking at the construct of structure. Now, a structure is going to be a grouping together of dissimilar variables under one name. Now, you remember, we've already seen groupings. We've seen arrays, but array is a grouping of a homogeneous data type. So all the data types must be the same. An array must be an array of integers or an array of char or an array of double, but they must be the same type. A structure is a grouping, but this is a heterogeneous collection of data types. So here what I can do is within this construct, within this structure, I can have different types of variables, int and char and double, and put them in all together. This becomes a very useful construct to us in C. The ability to group this together and to be able to use these as members of a single group makes programming easier and makes coding easier to read. So how does this work? We're looking at a structure, and here what we have is we're going to define this. This is one of our UDTs, one of our user-defined data types. So how is this done? It is going to use the C reserved word of struct, and then what we're going to say is we're going to give this variable type a name. Just like int denotes one thing and float another, we're now going to come up with a name that's going to denote this structure. So here I've called this, for example, this structure is going to be called person. Now what I'm going to have is my begin and end block, and this is indicating to the computer all of the variables declared inside of this are going to be part of this structure I've named person. So I got my variable declaration of char, 32 character array called first, a 32 character array called last. I'm going to have an integer called year. I'm going to have a double called PPG. Now also very important, notice the fact that this ends with a semicolon. You must have in your user definition of the structure, you must finish it with a semicolon telling the computer this is the end of this statement. You notice this is on multiple lines. This is very important to let the computer know, hi, not only is that my end bracket, but I'm done with the statement too. Now looking at this, again, it's going to struct this under the one name, and this one name here is person. But please remember, this is nothing more than what we're doing is defining this. We're saying to the computer, we wish to create a data type. No memory has been put aside at this point, and this is very important to understand. This is not where we're actually declaring or defining a variable. It's not the same thing. Where we're not, this point here, the computer is not turning around and putting aside memory. All we're doing is saying to the computer, here's the blueprint for this construct structure. When this structure finally is declared and used, now the computer knows to go and look at this definition, look at this blueprint, and it will know how much space to put aside. Just looking at this one, can you tell how many bytes are going to be necessary to put this into memory? Well, that's actually very simple. There's 32 bytes. There's 1 byte per character. There's an array of 32, so there's 32 plus another 32 character array, so that's 64 bytes. I add 8 bytes, 4 bytes for the year, because the year is integer. So what I've got now is 64 plus 4, so that's going to be 68 bytes. And then I'm going to need 8 more bytes for the double. So this brings it to 76 bytes in total. So every time this structure is going to be used and it's going to be put into primary memory, the computer must find 76 bytes. But again, this is nothing more than the blueprint. This is saying what the structure is going to be. This is not telling the computer to actually put it in memory. So how do we do that? We do that with our variable declarations just like we do with other variables. Here I've got a variable declaration for a variable I wish to label I that's going to be of the data type int. And then here I want to declare a structure. Which structure? The one that I defined as a person using this as its construct, and then I want to name that, give that variable the label of teacher. And again, end with a semicolon. So exactly the same thing. I'm just telling the computer, instead of the variable type int, which was one of the primary types, this is a user-defined, a structure. Go and look into person to find out how to do it and label it teacher. So this creates the integer variable enough space to store I, and then creates enough space to store teacher. So again, looking back at our memory map, let's see exactly what's going on. It gets to this line of code and it says, all right, go and find enough space for teacher. It goes into primary memory, and again, and I can't emphasize this enough, I stress this, the computer must find 76 contiguous bytes. They must be together. The computer cannot break up a structure into different memory locations. They must all reside one next to each other. So memory location 400 to 475, this is what's put aside. The 76 bytes of data is put aside, and now it's ready to be used. One note here, understanding when we're using this and we're going to want to use the address of it, the idea here is that teacher, the label teacher, teacher.first, and return the memory address of teacher.first.0. All of these are the same. Notice this one required the @ sign, return the address of. Little side note here, what am I doing there? When we use a structure, and we wish to actually use it in our program, and you're going to, otherwise why are you going to use it? The way that you look at an individual element of this structure is by using the dot. So here, what I have is the structure teacher. So I would use TEACHER, and then if I wish to use any one of these individual members of that, it would be with the dot and then the name of that variable label. So .year is what I would use if I wish to go into this variable of this instance of person. So looking at that, we move on, and now what I wish to do is populate it. So I will have teacher.year is going to be assigned 2005. That does that. Teacher.ppg is going to get 10.4. The computer will go and do that. And then we have our string copy teacher.first with Sam as the other parameter. Notice, I cannot use teacher.first is assigned, quote, Sam. That doesn't work here in this case because now we're using this as we do any other string. Just because the string is a member of a structure makes no difference. We treat it exactly the same way as we do any string. So if I wish to copy a character string into that memory location, I must use our friend's string copy to do that. String copy, as you see, it will also terminate. We'll put in the terminating character. Again, I go here and I say teacher.last mags, and it will go into the memory location for last. It goes and finds that here. And starting there in the array, it is going to put in MAGGS, and then it will terminate. It will put in the terminating character. So after that, this is what our memory map looks like after those 4 statements execute. Notice the memory location 400. Teacher refers the entire structure starting at 400. Teacher.first is going to refer to the character array starting at 400, and teacher.first at index 0 is the single character byte at that memory location. Having a label that refers the entire structure is going to be used in 2 ways. It allows assignments between 2 identical structure types. If I create a structure of type person that I have defined, and I'm going to create one that says mailman, comma, 1 teacher. The computer, as we know at this point, has put aside 76 contiguous bytes for each of these structures. So there's a mailman and there's a teacher in there. Now look at this assignment statement. This assignment, mailman is assigned teacher. This works. It's going to be a byte-by-byte transfer of everything that's in teacher will get put into mailman. So teacher.first, the first name was Sam. Mailman first name now is going to also be Sam. Last name was Mags. That gets put over. And why is that? Well, look at this, and because we know how a computer works, this is very easy to understand. Say this was at memory location, teacher was at memory location 400, and mailman here was at location 630 in memory. All that we're doing is we're saying memory location 400 there, go and put that byte by byte into Mailman. This passing the structure as a parameter to a function is the other way that we're going to use this name. Because again, this represents the memory address associated with the entire structure. So that's how come we can use this, just so we can remember the array name could be used as the pointer. Similar, because again, this represents the entire structure, the name can also be used to do that. This allows an easy transfer of large amounts of data. Another way that a structure is used. Say the structure had 182 members in it, variables inside of it. If you wanted to do that one at a time, think how tedious that would be. Whereas by doing this one statement and accomplishing it, doing the transfer exactly of there, byte by byte, allows us then to do it easily. So passing the structure of a parameter to the function allows easy transfer. Let's see this at work. What I have here is my person. I'm going to create a person type. I'll call it teacher. I populate it as I do. And now I'm going to call the function displaystats. And the function displaystats, what this is going to do is I am sending it a variable. What's the computer do every time it sees a function call before it does the function call, before it actually passes it? Do you remember what the computer has to do? I wish I had the Jeopardy music at the second here. Thinking for a second, it must always go. It cannot pass a variable. It must go and find the actual value because the value gets passed. So in this case, teacher, what's the value of that? Remember, that was the value 400. So that's going to get passed to here. So this is going to go here. We get struct person input. What happens at this point then? What is this? This is a variable declaration and definition in one statement. The computer goes, we have a function, a new call frame is put on the stack. It is going to go and is going to create a brand new variable called input of type person. It will find a new 76 contiguous bytes in memory to call input. It does that, and then here's our 400. This is exactly the same as if we had said input is assigned teacher. It will do a byte by byte transfer. So in this new memory location, it's going to have Sam and Mags and 2005 and 10.4. Now I go here, and let me clean this up a bit for us. And I have the line input.first is assigned Dunzel. Well, we look at this and you say, wow, first of all, that's not how it's done. I don't know why I've got that line of code in there if they haven't just said and creating the other slide that says you can't do it that way. If I had done my string copy for input.first, Dunzel, and put Dunzel into first, execution gets done here and it comes out there and it prints out teacher.first. Please assume this was the right one. Please assume that was string copy. I did that to see if you were paying attention again. All right, looking at this, assuming I had done that right, I get down to here. What's going to print out? Was this call by value or call by reference? Is this going to print out the first name of Sam, or will it print out the first name of Dunzel? And so I come here and I look, and let's see what happens. I turn around and I create the blueprint for structure. Again, we know as the computer goes through this, all this is doing is putting aside the definition, but it's not actually putting aside space in memory. It comes to this line, and now I'm doing the variable declaration. Now I'm declaring it, and I'm declaring it teacher, and so it finds the 76 bytes in memory. It goes and it populates with all of this information. Goes and puts in there, and there's our Sam Mags. All of this is at memory location 400 to 475. We move along, we display stats. That got changed with 400. got put into there. Go and find space in memory for input. The computer goes and finds free space, 76 contiguous bytes, calls that input, and then does a byte-by-byte copy of the data it got sent from teacher. So Sam Maggs 2005 10.4 gets put in there. The output this then is going to be what? Who can tell me what the output is? Is it going to be Dunzel or is it going to be Sam? I would hum the theme to Jeopardy, but I think that would be too embarrassing for you and for me. So let's assume now the time is up. Pencils down. Let's see what the answer is. The output of this would be Sam. Because the original is untouched, this was passed by value. Even though here we seem to be using memory addresses, and we are using addresses because of the way structure is, and the fact that the assignment is going to be doing just a byte-by-byte copy and not just sending the address alone like call by reference, this is a call by value. So how do you change this? So if the line print, how do I change it to make the line print out Dunzel? And I'm either going to leave this as a lab or part of an assignment. And I think about this, that's too interesting and too much fun. I'm going to leave that and not give the answer. I'm going to see how much you can put together. Probably do this in a lab. We'll see. So that ends the first part of our discussions of structures in C.